Hello, my name is Lee Seung-yup and I'm the presenter. I would like to introduce the virtual environment reconstruction of a vanished city, focusing on the serious game The Ruin Before. And those are the contents of our slide. And first of all, I would like to represent our research summary. This research uses three generative AI models to create audiovisual game elements such as background, NPCs, and the texture in the game. In the virtual environment, the protagonist can explore history by walking around a war-torn city and interacting with AI NPC of various professions. Based on GPS open-source map data from Google Maps, the game aims to recreate realistic scenes of real events by using game platform that is which is very familiar to the public. And this is our game story of our and all the images are generated with the AI. And the player meets the war orphan in the city center where the bombing passes. The child asks to find his parents. Walking on the rough battlefield, he encounters an orphan who has become an adult without finding his parents in the ruins. And the time passes by and returns to the peaceful city before the war broke down. Our research goals can be categorized into four main areas. First, using open source GPS information from Google Maps, we modeled lost cityscapes and buildings and stylized them with generative AI to create a city that matches in the atmosphere and the area of the past. And then upload the generated 3D model to Unreal Engine 5 to create a virtual city environment. And third, recreate the city in the virtual environment by creating an AI NPCs that can interact in the virtual city environment and reflect the culture, environment, and the common sense of the era. And last, build a variety of interactive and experimental content in the virtual city. In this project, we will use three different techniques to bring the life of virtual city at a specific point in the time. First, we create the 3D object of the fictional city using Cesium, which takes the GPS coordinates of the point in the time and creates the 3D object for it. Second, stylizations. We extract meshes for the 3D objects created by Cesium and use StyleGAN to convert meshes into period-appropriate styles. Finally, create realistic NPCs. We use transform using GPT to create NPCs that can interact in the created city and are given behaviors and personalities appropriate to the time period. This is our research status and Cesium. To generate the city at the point in time, we use the tool called Cesium. Cesium is a tool that enables efficient streaming and rendering of the 3D content such as buildings, trees, terrain, and point cloud. At the core of the tool is the ability to break very large datasets into small, manageable tiles that can be uploaded and displayed based on the user's locations and field of view. This approach enables smooth, responsive 3D visualizations of complex and large geospatial datasets in web browsers and applications. In this project, we want to generate a city by fetching 3D information at the specific location from Google Maps data by entering the latitude and the longitude. As shown in figure 1, and the pre-processing in the Cesium to extract 3D objects for the city for the desired year. And also, we looked at 4 conflict zones in total, prioritizing those for which we currently have map data from the Google to work with. Therefore, these are for in order: Iraq, Syria, India, Pakistan, and Israel and Palestine. We use the map data in then imported to the into Blender and separate 3D tool. For further modeling and to the design, we use the full-fledged game environment in Unreal Game Engine. This image is the showing in the Unreal, and this is the stylization with deep learning, our best presentations. And style transfer is the technique that uses deep learning and computer vision techniques to apply the style of the image or video to another image or video. The core idea of style transfer is to separate the content and style of the original image and transfer the styles to stylized image while preserving the content. However, when applied directly to 3D, this method performs poorly. As the time passes, the cityscapes and the material used in the construction vary from the place to place, as well as the degree and the deteriorations. Therefore, we wanted to enhance the immersions by reproducing 3D object created in the specific year and location by considering the characteristics of that at the time. For this purpose, we wanted to perform stylization based on the EEG's 3D method based on the NERF model, which has excellent stylization performance for 3D objects among style transfer mode method using deep learnings. Then first of all, the research team tried to stylize the 3D model of city data during instant NGP. However, instant NGP-based stylization code error occurred, and the learning process was not performed properly because of the non-number error occurred. Was generated during the learning process. Therefore, the result was not generated and only showed a black screen. So we looked for another way to do it, and it's called StyleRF. StyleRF uses the 3D scene representation and represents high-level features as the grid. The grid enabled style transitions by sampling complex 3D points and transforming the resulting the feature according to the style image. Two important designs were the sampling environment and content transformations called the SICT and the deferred style transformation called the DST. SICT maintains the multi-view consistency by transforming the characteristics of each point independently of overall statistics and of the sampled 3D point. DST transforms 2D features maps generated by volume rendering to significantly reduce the memory usage and perform style transformations efficiently. And here's the result of what StyleRF did. As you can see, we are able to successfully apply the desired styles to our 3D data from the original image data. Transport Transfer uses GPT-2, and that is a large-scale language model developed by OpenAI. It has been pre-trained on various kinds of text data and performs particularly well on the natural language understanding and generation task. GPT-2 can generate logical and coherent content based on the text and is used for the variety of language process task. including some answering some questions and writing articles and generating some stories. The models is based on the transformer architecture and is capable of generating highly sophisticated text by learning various language patterns from the large amount of data. This is the overall flow chart of the task in this study. And we are aiming for total four deliverables. First, we are aiming for the serious game simulator game and build an efficient game production pipeline with a low budget with small team. And also create an AI game NPCs with different identities. And lastly, implementing 3D modeling with generative AI. We anticipate three research outcomes. First, the generated virtual cities will provide users with the opportunity to walk through old or defunct cities, evoking the memories of the past and experience the cultural heritage. Second, historical events can be used to provide players with the educational experience. Games created through accurate and in-depth research can increase players' awareness and understanding of the past events. And finally, the game can emphasize the importance of peace and cooperation, not just the destructive aspect of war. This can help players raise the awareness of alternative solutions to war. A key element of the project is the active use of the artificial intelligence technology to create a simulator game based on the data from Google GPS information. Stylization based on 3D modeling built from open source information is used to make the production process much faster and more efficient. The production process is much faster and more efficient, so the AI technology utilized in this case can dramatically reduce the time of the long production process. And AI can also be used to give NPCs different behaviors, personalities, and identities to enhance the quality of the game content. This way, you can generate creative ideas and build an efficient game production pipeline. So those are our push dates of this project, and we have been working on real work since this May. And are currently working on the 3D stylization, AI NPC creation, and level designing in Unreal Engine 5. After that, we'll be doing final composting and getting ready for the beta testing. So that is our last presentation slide, and this was your presenter Lee Sung-yeop, and thank you for watching.